Welcome back to Pre-Calc. Our objective today is going to be to look at some more log functions. We're going to look at graphing them today. I've got the checklist on the screen. You know what to do from here. All right, before we get going with graphs, I want to do a quick warm-up, make sure we're good to go on these. So force pause on your screen. Can you go ahead and try this warm-up? Hit continue when you're ready to check your answers. All right, I've got the answers on the screen. Remember, if the base is not written in, it's understood to be 10. Go ahead and pause if you need to make any corrections. All right, so a little bit more review before we jump into it. Relations who are inverses of each other have graphs that are symmetric about what? Do you remember? About the line y equals x. So force pause on your screen. You don't need to write anything down, but just decide which of these are inverses and which are not. All right, so the first one, these two are inverses. Nice reflection. Here, not quite, okay, and here, yes, these are both inverses as well. Nice reflection about the line y equals x. All right, force pause on your screen. Can you just go ahead and write the two expressions I have here kind of diagonally as I have them? All right, so let's try converting these. So this first one, is this in log form or exponential form? This is in exponential form. Let's convert it to log form. So if I'm going to convert, I first need to write the term log, right? Now, look at where your base is. Your base here becomes your basement, and again, it's base 10, so I don't have to write it in, but I'm going to. And then remember to switch sides to get what's called your argument, and then equals, and whatever your exponent was in exponential form should be what's by itself in log form. Remember, the log always reveals the exponent. All right, now let's come to this one. Is this one written in log form or exponential? This is written in log form, so let's convert it to exponential. So start with your basement. It's 10. That becomes your base here. Switch sides to get your exponent, and then equals, and whatever your argument was here becomes your answer in exponential form. Okay. All right, so I want you to notice that this expression and this expression are inverses of each other. Do you see that? How I've inverted x's and y's? Like here I had y equals 10 to the x. Now I have x equals 10 to the y, right? So these, I want to notice, are inverses. Okay, and also keep in mind that these are the same thing, right? Just two different ways to write the same idea. So if these are inverses and these are the same, then these two are also inverses. Okay, so take a look at these expressions. Can you go ahead and circle or highlight these two? These are inverses of each other, okay? So exponentials and logs are inverses as long as their bases are the same, okay? And now if this is true, then this graph and this graph should be reflections about what line again? About the line y equals x. Let's take a look at them. So here we've got, let's make this wider. So here we've got two graphs. This red graph, is this the exponential or the log? That red graph is the graph y equals 10 to the x. That's your exponential function. The orange graph is the inverse, and what would the inverse of 10 to the x be? That would be log base 10 of x. And again, it's base 10, so I don't have to write that particular base, but I am going to in this case for emphasis. All right, first pause on your screen. Can you go ahead and write domain, range, asymptote, intercept for y equals 10 to the x, as well as y equals log base 10 of x. All right, let's fill these in together. So looking at the red graph, the exponential graph, what is the domain here? The domain is all real numbers, right? This goes on forever, grows very, very, very quickly, right? All right, what is the range? Range is 0 to infinity. Do you want a parenthesis or a bracket on the 0? Parenthesis. We don't ever quite get to 0 here, okay? What about the asymptote? The asymptote is y equals 0, and we've got an intercept at the point 0, 1, right? When x is 0, y is 10 to the 0, which is 1. Okay, now let's look at the inverse graph. Y equals log base 10 of x. Remember, inverse inverts x's and y's, so like our domain and range should be inverted. And where I have a y, I should have an x and vice versa, okay? So domain, if I look at the orange graph, that is indeed 0 to infinity, just like the range for the red graph. The range should be the domain of the red. Well, it is. It's goes down and up forever. This is not an asymptote. It continues to grow. It just grows incredibly slowly, okay? So the exponential functions grow very, very quickly. Log functions grow very slowly. This continues to increase on its entire domain, just very slowly. So this is all real numbers. Our asymptote here is the y-axis, so that's x equals 0. And the intercept is 1, 0, as opposed to 0, 1. Okay? Now these are the general shapes no matter what your base is. So for example, if I wanted to graph y equals 2 to the x, it would have this same general shape, it just wouldn't grow quite as fast as 10 to the x, meaning that the inverse log base 2 of x would grow slightly faster than the orange curve that I have graphed here, okay? So the larger your base, the steeper the red graph is going to grow, or the faster it grows, okay? The larger your base for the log, then actually the slower it grows. All right, so take a look at your log function one more time. Notice that your x, your domain, it was always what? It was always positive, right? Why is that? Why could we never have a negative x in here? Well, let's try converting this. So I would start with the base of what? Base of 10. What would my exponent be? Exponent would be y equals x. If I take 10 to some power, even if that power is negative, that would just make it a fraction, right? Or 1 over something. So I could never get a negative value no matter what my exponent is here, right? So our conclusion, would you write this, please? You can only take the log of positive numbers. And we talked about that last time as well, but this is really, really important. So please write that. You can only take log of positive numbers. All right, so what are the inverses of logs? Exponentials. Okay, so first pause on your screen. Can you go ahead and copy the table? All right, so we're going to assume that f and g are inverses. So if I want to find the inverse of log base 3 of x, then that would be the exponential with that same base. So that would be y equals 3 to the x. All right, and first pause on your screen. Go ahead and try the rest to continue when you're ready to check your answers. All right, I've got the answers on the screen. So again, exponentials and logs are inverses of each other as long as their bases are the same. So for this last one, I'd have log base e of x, which remember is natural log, which we write as ln. First pause on your screen. Can we move myself here? Can you go ahead and copy the 4 functions I have? All right, so we want to talk about which transformations now. Now, transformations are going to work the exact same way that they've been working forever for all our functions. So remember, outside the parenthesis is going to be a vertical transformation. Inside the parenthesis is going to be a horizontal transformation. And then we also want to find the domain and range of each. Now, let's take a look again at this parent function here, this orange function here. Notice that, was it the domain or the range that was all real numbers? It was the range, right? But the domain was, for the parent function, was 0 to infinity. So if we have some kind of horizontal shift or reflection, notice that that domain is going to change. All right, let's try this one here. We've got log base 10 of x plus 3. That 3 is on the outside of the parentheses. So will that shift the parent function up, down, left, or right? This is going to be up. I'm just going to put u for up 3. All right, so if I take a look at the graph, it should look something like that, right? Has the range changed? No. Has the domain changed? It has not. We've not shifted horizontally at all. So the domain is still 0 to infinity, parenthesis on the 0, and the range is still all real numbers, right? Okay, next I actually want to do this one kind of in the bottom right-hand corner here. Whoa, just kidding. Okay, so the 4, what is that going to do to our parent function? Shifting it up, down, left, or right? That is going to shift it left 4, inside's opposite, right? What about the minus 5 on the outside? That's going to be down 5. All right, so let's take a look at this graph. So we've gone left 4, down 5. So has our range changed? It has not. move it here a bit. It's not. Our range is still all real numbers. What about our domain? Yeah, our vertical asymptote is now at -4, right? You can see, okay, what would make the inside 0? Well, that would be x equals -4. So our domain is now -4 to infinity. Make sure you've got a parenthesis on the -4. The range is still all real numbers. Okay, let's take a look at this one. Y equals log base 10 of -x plus 3. All right, now remember, inside's opposite, so you have to think, okay, what would I do to get x by itself in this set of parentheses? Well, if I set the set of parentheses equal to 0, I would first subtract 3, right? So that means I'm going to move left 3 first, and then I would need to divide by -1. So that's going to be reflect about the y-axis, right? All right, so here's our graph of the parent function, okay? Then I'm going to add 3 to the inside. That's going to shift left 3. And then I'm going to put a negative in front of the x, and notice that I take that whole thing and reflect it about the y-axis, okay? All right, so has the range changed? No, but what's the domain this time? This time the domain is -infinity to +3. So domain -infinity to +3 because of that reflection, right? Range is still all real numbers. All right, let's try this last one. The -3 on the inside is going to shift the parent function which way? Going to shift right 3. And what does the negative on the outside do? Reflects about what? Reflects about the x-axis. It is a vertical transformation, right? So if I flip my y's, that's going to be about the x-axis. So let's take a look at this graph. So here's the parent function shifted to the right 3. Then if I put a negative and flip that over the x-axis, we look like this. So has the range changed? The range is still all real numbers. Now the domain goes from what to infinity? From 3 to infinity. So domain is 3 to infinity. You can just set this equal to 0 to find where we start, and the range is still all real numbers. First, pause on your screen. I want you to do 3 things for me. Go ahead and copy this function, write down these words, and then just do a kind of quick XY formula and do a rough sketch of this graph. All right, we are back. So we are looking at this function. We're going to try to graph this by hand. Now, the parent function would just be log base 2 of x. But we've got 2 transformations here. What does the 3 do to the parent function? This is going to move up 3. And what about the +1? Left 1. All right, so now let's take a look at the asymptote. So for the parent function, let me see if I can grab this line here. There we go. The parent function, we started here. This is where our asymptote was at x equals 0. But we've gone left 1, so now the asymptote is at x equals -1. Again, take a look at what value would make what's called the argument, the stuff in parentheses, 0. Okay? All right, now x-intercept. Let's take a look there. You know what, let's change that to y-intercept. So what do we get when x is 0? Okay, well, let's plug that in. We'd have 3 plus log base 2 of 0 plus 1, and 0 plus 1 is 1, right? So let's simplify this part. 2 to what power is 1? Well, 2 to the 0 power is 1, so this is 3 plus 0, which is 3, right? So I've got a y-intercept at 3. Again, 2, this log reveals the power, so 2 to what power is 1? That would be 0, but you still have got your 3 here, okay? All right, our domain, well, again, the domain of the parent function was 0 to infinity. I've shifted to the left 1, so this time we'll have -1 to infinity. What's our range? Our range is all real numbers, right? So let's plot at least one more point to kind of get a feel for this graph, and then we will connect our points and be able to answer the others. So here's what I look at. I come here and look at the argument here, okay? And consider your base. What is your base? your base is 2, right? So what I would ask myself is, okay, what x value do I need to use to get my argument to match my base? So what x would I use to get the highlighted part to be 2? It would be 1, right? So I'm going to test x equals 1. So that would be 3 plus log base 2 of 1 plus 1, which is 2, right? Let's clean this up. I've got 3 plus, what is log base 2 of 2? That's 1, right? Because it says 2 to what power is 2, and what power is 1. So this is 4. So when x is 1, y is 4. So let's plot that. Okay. Let's try another one like that. Let's see if we can find some more nice points here. Grab a different color. So come back. I'm going to highlight my argument here. So let's come up with the next power of 2. So the next power of 2 would be 4. So for what x value would I use to make the highlighted part be 4? I would use x equals 3, right? So let's test x equals 3. So I'm going to plug 3 in here. That would be 3 plus log base 2 of 3 plus 1, which is 4. Clean this up. I've got my 3 plus, what's log base 2 of 4? That's 2, right? Because it's 2 to what power is 4? The power is 2, and 3 plus 2 is 5. So when x is 3, y is 5. And again, I'm just picking these nice x values that give me a power of 2 inside the parentheses there. Okay, now I kind of get a feel for this graph. Remember, it does increase just very, very slowly and then approaches negative infinity here. All right, so is this function increasing or decreasing? This one's increasing. Is it continuous? It is. I can draw this without picking up my pencil. Is it bounded at all? It is not. And now let's talk end behavior. So let's go limit as x approaches negative infinity of f of x. Actually, let's do positive infinity. So as we go to the right forever, what do the y values approach? The y values approach positive infinity. Now, take a look here. I've got this wall, right? I cannot go any farther than x equals negative 1. So I'm going to say the limit as x approaches negative 1 of f of x. So as I approach negative 1 for the x's, my y's approach negative infinity, right? And technically I'm only approaching from the right-hand side, so I should technically have a little plus there. But since this is somewhat new notation, I'll take it without the plus. This is our end behavior. Notice that I can't do x approaching negative infinity because the farthest I can go to the left is x approaching negative 1. All right, you all, that's all I have for today. I will see you next time.